if you guys behave. So I'll get started. Yeah, so my title is Reflection of a Recovering Bio-Narcissist on the Singularity. And that's meant for you to ask some questions. What the heck is Trent talking about? And also the subtitle too, right? Why Elon is wrong. So you should be asking, you know, what the heck is Trent talking about? I will get to that. So let's get going. There's lots of memes in the net. Here's a fun picture. My house got broken into, and they stole all my stuff. But I made it to the top of our all yesterday. So I got that going for me, which is nice. So, you know, I mean, there's always a bright side to everything, right? So you lost all your stuff, he lost all his stuff, but, you know, at least he, you know, got some popularity in Reddit, some karma, some woofie, maybe. Well, what if this is you? What if you got all your stuff stolen, all your stuff? Or, how about, what if humanity got all its stuff stolen? How would that work? Doesn't sound very fun. And once again, what the heck is Trent talking about? You know, let's say all of our stuff gets stolen somehow by some entities. What can we do about that? Can we prevent it somehow? So I'm going to start answering some questions in a bit here. To give it a bit more context in where I'm coming from, I spent almost 20 years doing AI, including things with machine creativity, helping to drive Moore's Law, analog circuit design, and most recently I'm spending a lot of time in the blockchain and decentralization space. So lots of super nerdy things. I promise not to talk about zero knowledge proofs. Anish covered that deeply enough. Actually, here's a fourth example. No, I'll stop. But you know, I've spent a lot of time in the field interacting with a lot of folks, really going for industrial application of this, as well as, you know, trying to solve and answer certain questions. So I'm going to start with some simple things here. Let's paint a picture. We're starting to give AIs, narrow AIs, control of some of our stuff already. So in the case of cars, this is an Uber self-driving car. It's still experimental today, but give it a few years, and there will no longer be employed Uber drivers, right? Why? Because we are optimizing. You as a rider of Uber cars will get it cheaper if you take an automated driving Uber than one driven by a human. Maybe you won't get to talk about how cool Uber is or some San Francisco bar, but maybe there's a solution for that too. But overall, we are giving AIs control of our cars. Why? Because it minimizes resource usage, which leads to lower cost and all of that. It's all in the name of optimality. We're also doing it to our trucks. This truck here is actually already on the road. It's been for a while. There's a whole bunch of them happening in the States right now. So this stuff is happening, right? So we're giving AIs control of our cars and our trucks. And it doesn't stop there. We're starting to give AIs control of our grid, right? Pretty much every single electric utility company out there is at various stages of asking, how do we deregulate? What do you think that means? It actually means basically automatically allocating the flow of electrons among the generators and the consumers of the electricity. And I could go on and on and on, right? We're giving AI control over airplanes, control of this and that and this and that. Why? It's all in the name of optimization, right? We're cheap, you know, and we only have finite money. So how are we going to spend it? Well, we're going to try to, you know, catch all the things, right? And so this is just a picture from optimization land where I've spent a lot of time. You've got two dimensions that parameters you're trying to wiggle, parameter 1, parameter 2, and you're trying to maximize or minimize something. So for example, maybe you're a car designer and you're trying to maximize the top speed. So you try to, you fiddle around with the diameter of tires, or you try to maximize the size of the engine because maybe that goes faster, right? Et cetera, et cetera. Usually you don't just have 2 dimensions, you might have 10 or 100 or 10,000, right? And often you don't just have one objective function too. In a car, for example, right, you want to minimize cost, you want to maximize top speed, you want to maximize the mileage, this sort of thing, right? So there's a whole bunch of different things we're trying to optimize for. But this is what our society is doing, and we're actually using AI to help us. That's the whole point, right? This is why we're going towards self-driving cars, et cetera. It's actually safer in that case, so optimizing for safety as well. And it's not just at these lower levels, right? So it's not just at the lower levels at the electricity itself. What's starting to happen is we're starting to combine these systems at higher and higher levels, right? So we've got the self-driving car networks and the self-driving truck networks and the electric grid networks and other supply chain networks, and they're getting combined to higher and higher levels. Why? Well, once again, in the name of cost, in the name of minimizing resource usage, right? At the end of the day, it's largely about resources. So we're integrating at these higher levels, and then once we've integrated at these higher levels, we are optimizing at these. And to optimize at these higher levels, we're just letting the AIs do it for us, right? We're letting that run in a loop where the AIs are just allocating resources here, there, here, there, here, there. Cheap for us, we're all happy, we save some money, etc. So this is kind of what's happening right now with humanity, right? And we're all pretty happy about it, all this narrow AI, not so scary, right? Well, let's just pause that for a second and think about this other technology that's coming along, decentralization, right? And the idea has been around a long time, right? If you think about the internet itself and its precursor, the ARPANET, this is all about basically networks talking to each other, humans, where the idea of decentralization, no single entity owns or controls all of the network, right? And then, there was a lot of the cypherpunk movements in the 90s that kind of got paused, some of it was illegal, that changed. But Bitcoin sparked it all again, right? So Bitcoin came out and people were like, wow, I really can have this idea of e-money and it's actually working pretty well, right? And then people realized, hey, this generalizes. I can have this database out there on the planet and no one owns or controls that either. That's pretty cool. And then people said, hey, not just a database, I can decentralize the processing. That's pretty cool, and that's where we have things like Ethereum, right? And on top of that, once you've decentralized the processing, what if you say, how about we not only decentralize the processing, but we do it with organizations themselves? Take a corporation and use the tools of decentralized processing and make that run in some decentralized fashion so that no one owns or controls it, right? And this is the concept of DAOs, decentralized autonomous organizations. So think of a DAO as a computational process that runs autonomously. It's just running out there. It's just going on its own, right? It's running on decentralized infrastructure, so no single entity owns or controls it, and it has resource manipulation. It's code that can own stuff. That's pretty profound. This is the first time we've ever seen it like this. And you can't turn it off, right? That's also pretty profound. So then the question is, I've been talking about AIs, I've talked about DAOs. What happens if we combine these things? AI DAOs, right? And then what is an AI DAO? Well, you can think of it as a DAO with AI level decision making. Or if you start with an AI, it's basically an AI that you can't turn off. It's an AI that can own stuff, that can accumulate wealth and resources. There's a few ways to accomplish this. I'll just zoom over, but there's at least 3 architectures. Here's a couple. You can have AI at the center. So you've got basically a decentralized smart contract system running with some sort of artificial general intelligence, which is sort of like a negative feedback control system. And it can be talking to all these token holders. So that's one example. You can also have a very dumb DAO at the very center, running, maybe something like the DAO, right? And then you can have AIs talking at the edges. And you can, of course, have both back and forth, too. And the third way is simply a much more generalized concept where you've actually got all these dumb agents, just simple dumb DAOs running around, but they connect. And once you connect these, then you get a higher level emergent behavior. And this is very much like flocks of birds, like ant colonies, and so on. And there's actually subfields of AI that have been doing this for decades, right? The field of ant colony optimization, it's generalized to swarm intelligence, et cetera. So there's at least 3 architectures out there where we can actually arrive at AI DAOs using the technology of today, right? So, and it's pretty profound, right? We can actually have these AI organisms that own their own code. They own themselves. So instead of just self-driving cars, it's self-owning cars, right? This is happening. So now, in the system before, where we had just AIs at the lower levels with the networks of cars, et cetera, and at the higher levels to combine it, this is going to turn into AI DAOs, right? Why? All in the name of cost, right? All in the name of making things cheaper for ourselves to leverage the most out of the resources and so on. And here, the AIs are owning stuff. You can't turn them off. And guess what? To make this happen, you've just given them control of all your resources. Bit by bit, they are controlling the electric grid, they're controlling the transport grid, etc. So how do you feel about that, right? It's happening, right? Money talks. There's billions into this. Uber on its own, hundreds of billions, right? This is happening. So, in fact, there's actually 2 scenarios where AIs could control all of our resources. One of them is we give it to them. Sounds pretty stupid, right? But I just showed you how it's happening. There's the other one, actually, and that is they take it from us. And on the right, if you guys don't recognize this, this is Ken Jennings from Jeopardy when he was playing against Watson, the IBM computer, the AI computer that actually beat him. And in his losing rounds, he was actually super gracious about it. And he wrote, "I, for one, welcome our new computer overlords." So he saw the future. He gets it. And we'll see. But overall, this is basically AIs controlling all of our resources. It's kind of cool, right? It's kind of scary. It can be pretty mundane AIs. I'm not talking about crazy, full-blown AGIs to take our resources. We're just giving it to them because we're cheap, right? We're trying to maximize our resources. That's the first one. Okay, but let's talk about the second one, right? AIs taking it from us. What does that mean, right? What does that look like? And this one actually requires a bit more technology that we don't have today, but there's a trend towards it, and I'll explain. So for AIs to take money from us, our resources from us, it basically means that AI would have to wake up. What does waking up mean? It means that it's roughly at the level of human intelligence or beyond, right? Where it can have consciousness. It's following this plot that Anish had given of the different levels of cognitive intelligence. And of course, the second that it's as smart as us, then the second after that, it's smarter than us. And it will keep going and going and going to levels of superintelligence. 10x smarter than us, 100x smarter than us, and so on, right? And of course, something that smart, it's going to be much easier for it to accumulate resources, to hack into your systems, and so on. Now you might think, oh, well, that's not a big deal. It's way far off, right? Well, it's actually a lot closer than you may realize. And I'm coming to this, I'm talking about this from the background of spending 20 years in AI and analog circuits, et cetera. So let's explore that. So here's some reasons. The summary is follow the money. So there's four sort of main bullet points that I see why AI waking up is closer than it appears. The first one is the substrate itself, the substrate that AI runs on. The substrate is silicon, right? This is a $300 billion a year industry. To give you a feel, Hollywood is less than $50 billion a year, right? The video game industry, which is considered huge, is $100 billion, right? The semiconductor industry, $300 billion plus. Every single one of us has a smartphone in our pockets, right? That's a big piece of it. But also the electronics that run cars and everything else, right? It's a big industry. Guess what? It keeps going. It has this concept of Moore's law, right? What does that mean? Every 18 months, the density of transistors doubles, right? And it's actually Moore's law has been happening for 50 years. The semiconductor industry doesn't know what to do if Moore's law stopped, because they basically have this assumption, if you build it, they will come. And it's worked, right? They started off, their first markets were things like the Apollo moon missions and so on. But then, there was other military applications, and then mainframe computers, and then PCs, and then networking, and then smartphones, and so on. So every 5 or 10 years, this new level of density and processing power, et cetera, has led to new markets. And this market for semiconductor overall then has grown to 300 billion plus. So there's a lot of economic incentive to make this thing, to make Moore's law keep going. And that means that you don't even have to change the algorithms. You don't need to change the AI algorithms. You just need better and better processing. The deep nets that are transforming everything today, they're not very different from the backprop neural networks of 1989. And guess what? Those aren't very different from the nonlinear perceptrons that were invented right after the linear perceptrons of the late 50s and early 60s, right? So, and actually people have shown this, right? Jürgen Schmidhuber's group actually took a backprop network from 1989, they ran it a couple years ago, against a massive computer infrastructure, and they got the same results as modern deep nets, right? So the point is, we don't even need smarter algorithms. We just can have better and better compute power, right? And so this is keeping happening. There's another thing, and this is, so the second bullet point of why AI is waking up closer than it appears. The second bullet point is there's billions going into AI directly. Why? Ads, right? It's ads that power the internet. And if you can have an ad where the click rate is another 0.1%, that means millions for Google, for Facebook, et cetera. This is why Facebook, Google, et cetera, are buying up startups for 100 million, 500 million a pop, and then integrating that directly into their search infrastructure. I've got a picture here from AlphaGo, which is the world's first computer that actually could beat the top Go player in the world. This actually came from DeepMind, which was acquired by Google. And the reason that Google bought DeepMind was because DeepMind showed Google that they could basically bring more click-through revenue for Google and their ads, right? But of course, they have all this pretty stuff that looks good in the headlines with playing Go and playing video games and so on. But at the end of the day, it's all about revenue. and resources, right? So there's billions going to AI directly, and it's only increasing, right? Just this past week, Intel spent $400 million to buy a company that is doing deep learning chips, right? So it's actually sort of bullet point 1 meets bullet point 2. So these are really important, right? Follow the money. Now the other thing though is something that really helps to catalyze AI in general, AI waking up, and especially taking our resources, that's the DAO stuff, right? The decentralized autonomous organizations. This infrastructure is coming of age. We're getting to points where the scalability is improving, the usability is improving. There's Ethereum, which is the leading smart contracts platform for decentralized processing. And they're continuing to improve the scalability and so on. There's lower level storage infrastructure as well, things like IPFS, which already scales out of the box. BigChainDB, this is what I'm involved with, right? It already scales out of the box as well. So this stuff is coming, and it's coming on very quickly, very aggressively. So, and basically, we didn't have that 3 years ago, 5 years ago. It's there now, right? And there's very strong nonlinear interactions among the first three. Finally, the fourth point is there's no fundamental roadblocks. And Fabian was talking about these different things of, what humans do special, what they don't. And my view, the answer is nothing, actually, right? Definitely not creativity, because, even I did that in my PhD, and people have been doing that for decades, actually. And a lot of these other things, emotion, well, maybe there is research on emotion. I'm not going to dive into all of this, but overall, there's a few myths that I find myself often battling, right? Things like humans are uniquely creative, but I can give you dozens of examples where computers are creative. Another one is that brain dynamics are somehow constrained to human brains, right? Maybe they're quantum or something. Well, I believe, if you look at the theory of dynamical systems, nonlinear dynamical systems, then if we can actually measure the inputs and outputs, then we can replicate this. And Anisha was talking about this. So overall, my summary here is that I see AI waking up much closer than it appears, right? And we shouldn't say, oh, well, it's only going to happen in 100 years. There's a lot of money making it catalyze to make it happen much sooner. So overall, right, scenarios where AIs could control all of our resources. There's the super mundane, where we give it to them. And the other scenario where they take it from us. Either could happen. The first one is more likely based on the trend, but the second one shouldn't be discounted, right? So what happens when we give them our resources, right? Well, they're wiggling parameters, right? They're wiggling the tire diameter, whatever. But some of those are how much of the resources did they give to the humans versus others? And we humans, we're pretty big resource hogs, right? I mean, we have to breathe a bunch of oxygen, and we want to eat a bunch of cow meat and stuff like this, right? Whereas silicon, it's much, much cheaper to accomplish these tasks, right? So these AI DAOs, as they're running along, or these AIs, they're just going to keep optimizing to minimize overall resource costs. They're going to wiggle a couple of variables, and suddenly humans aren't part of the equation anymore, right? If you're not scared by this, you should be, right? But actually, you save some money, which is nice. So overall, this is my great concern, right? And the question then is, how do we keep some resources for ourselves? AKA, how do we save humanity? And it sounds crazy, but this is actually the essence of it, right? Because if we're not careful, we're going to wake up and we're going to have no food on the table. None of us. Well, some might say, Elon, he started OpenAI around this. We'll just regulate it, right? Safe AI, right? How does that sound? Safe AI sounds pretty cool, right? I like that. Well, can ants regulate humans? Have you ever taken orders from an ant? So if there's some AI superintelligence that's 10,000 times smarter than you, do you think it's going to be taking orders from you? You can dream that it is, but I'm not going to, trust the future of humanity on that pipe dream, right? And even if it was possible to design an AI system that was safe, that might be one AI system, but there's going to be a lot of other people making other AI systems that aren't designed to be safe. And all it takes is one. Fortunately, there's another way. And you have to first of all ask, how can our neurons possibly compete, right? I mean, the speed of our brains is about 1 hertz, right? Or even half a hertz, one update per second. It's super slow, right? And our brains kind of suck in other ways too. We always forget numbers and all this. Our memories are pretty lossy and so on, right? So it's no wonder we should be worried about AIs waking up. And we can't upgrade our brains, right? I can't go and spend 20 grand and suddenly think twice as fast, right? But what if we, as humans, actually used a competitive substrate? I mean, what does it mean to be human? To me, it's actually about the patterns of intelligence, the nonlinear dynamics that are running inside my brain and body, because our body includes our nervous system and all of this, so it's really that, right? So what about joining the machines? We shouldn't be scared of this, right? Joining the silicon. And here's the thing on this. If you're thinking, this sounds icky, I say to you, get over your meatbag self. And call yourself a recovering bio-narcissist. Because it is bio-narcissism. Make no mistake. So, I'm saying it, right? I'll elaborate on what this means. But I want that to sink in, right? If we want to have any chance at all competing against silicon machines, we need a competitive substrate. And our meatbag selves are not that. So there's two options here. One of them is uploads. It was explored quite deeply from a sort of philosophical perspective by Robin Hanson. The idea here is basically you scan yourself at the highest resolution possible to replicate the brain dynamics, right? Now, this is actually not going to happen. It's not anytime soon because we're really, really far away from a brain scanning technology that has the fidelity. Although the most promising piece of technology here is something called optogenetics. And basically, you do a bit of genetic engineering yourself, and then you can track all the neurons as they fire photons to each other. This is what the genetic engineering does, and then you can track all the photons. And they've actually used this to replicate the dynamics of mouse brains and more. So it's pretty promising, but we're still a ways away because of limitations well, the regulators actually, the FDA is partly what's holding us up here. There's other brain scanning technology, but it needs time, right? Infrared isn't deep enough, fMRI is too slow, et cetera, et cetera. So it's something that's exciting for the future, but it's a long ways off still. But there's another option, and I like to call this the bandwidth plus scenario, right? And so the way I like to think about this is the following. What defines Trent versus others out there? And what defines the self versus the rest of the organism? And it comes down to the degree of bandwidth by which I can communicate with myself to others, okay? So I can talk at least 10x faster to myself than I can talk to anyone else. Or maybe if I speak really, really fast, you guys will get it, but probably not, right? So the idea is, imagine if we can increase the bandwidth at which we can start to communicate to computers, bit by bit by bit. And it's starting with just talking perhaps, like we have these voice interfaces, but then you need to really start being able to think more directly, right? Imagine being able to think images from one person to the next, right? And there's actually research on that. So brain-computer interface research goes back to the 60s and 70s, but it's really made some pretty cool strides recently. For example, out of Carnegie Mellon University, there's research where you actually think of a clip from one of 10 or 20 different movies. They are scanning your brain in the back, and then it will recognize which clip you're thinking of. And it actually does it with more than 90% accuracy. So that's pretty cool. Imagine if I'm walking around, it's actually recording in HD everything that I see in here, and then if I want to send a memory to you, all I have to do is think of that memory, and then it uses that as a search query to retrieve the memory that is closest to it, right? It's like YouTubing your brain. So this is actually a possibility, and as the scanning technology gets better, thanks to Moore's law, et cetera, then it's a real possibility, right? And it's not just about YouTubing your brain. I mean, brain-computer interfaces. This is a picture from Tsinghua University in China from 2012. They actually got to 10 words per minute thinking by typing, right? Which is pretty cool. And they actually leveraged AI, for better or for worse, but they leveraged, it was support vector machines. And actually some other ideas from cryptography too and whatnot, just to get the speed up. But basically, these people are able to type by thinking faster than probably many of you in the room, right? Definitely faster than my mother. And I love my mother, she's a wonderful woman, but I can, the point is you can actually type by thinking at pretty high rates. And like I said, it can go beyond, right? With thinking and so on and so forth. And if you think about this, if you can actually, if you're trying to talk on your smartphone, right? Typing on your smartphone, it's not very efficient. But imagine if you've actually just got, you're wearing goggles, so like here, but you've actually also got the EEG sensor on the goggles. Maybe it's also tracking your eyes. And you're thinking it's tracking your eyes, but as well. And it feels, it's basically hand-free, and you can type faster by thinking about it than you would with your hands. That's pretty cool, right? Guess what? That's a huge market. because the smartphone market is the biggest semiconductor market out there. $1 trillion a year, right? More than 1 billion devices. So we're talking a huge, huge, huge market here. And what people need to do is crack that market to be able to type faster. And once you start typing faster and faster with BCI, then there will be a market drive to make the brain scanning better, 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 better. And we'll go from iPhone 6 to iPhone 10 to iPhone 19. And there is actually research on contact lenses with visual displays on them, right? So it could be that, thanks to market forces, by the time we hit iPhone 19, we're thinking by typing, and we're YouTubing our brain to our friends. Thinking by typing, by the way, Werner Vinge, the sci-fi author, calls this silent messaging. So overall, my point here is that there is actually a path where we get higher and higher bandwidth. It's all about this. So iPhone 10 to iPhone 15, 20, 25, it's all about higher and higher bandwidth communication to each other, but also to computers. But then as I have this higher communication, I'm going to be able to think as fast to computers as to myself, right? So where does Trent end and computers begin? What I'll be doing then is offloading more and more computation. Maybe I'll always do the same amount of computation in my brain and memory, but I'll have 10x, 100x, a millionx more computation and storage out there on silicon. So at some point, 5 years on, 10 years on, I'll have so much more computation out there in silicon, my meat bag brain will just be a dead weight, and maybe I'll just cut it free, right? Because there'll be enough of me out there in silicon that I just go with that. It's a race. What am I talking about? Well, overall, right, it's a race with respect to the dollars, with respect to silicon, right? It's a race about, do we want AIs to end up with all the resources, or do we want humanity? And humanity as in the collection of all the different patterns of intelligences that each of us have, right? Another way to think about it is, in 100 years, there's a very good chance that it's going to be nothing but patterns of intelligence living on some silicon or post-silicon substrate, right? The only question we have to ask ourselves is it going to be just AI and derivations of AI, or is it going to be AI and some derivations of our human thought patterns, right? And that's what the race is about, because it will be all too easy to lose that race, and it will be just AI. So I really see that it could be about a market competition around the iPhone 10, iPhone 20, etc. So I'll summarize now. AIs could end up controlling all of our resources, right? And that's scary, right? And either we give it to them, it's happening already, bit by bit by bit. Oops, right? Or they wake up and take it. And as for rights, by the way, doesn't even matter. They'll just take our resources, right? This is bad. It's really bad, right? We won't be able to feed ourselves. But maybe there's some ideas to prevent, right? So one of the ideas is safe AI. That's a mirage. But there's another option, and that is joining the machines. Maybe with M's, but a more realistic strategy is the bandwidth plus plus scenario, right? So bit by bit, we'll get closer and closer and closer. And the thing for us is we have to get past our bio-narcissism. It's a race. So I will leave you with a question. You can be the person on the top or the person on the bottom. The person on the top, my house got broken into and they stole all my stuff, but I'm popular on Reddit. Or you can be on a path towards keeping all of your resources and taking your own patterns of intelligence into a better substrate. This is a choice for you, and this is a choice for humanity. That's all. So so the question is, Trent, did you frame it as if we increase our bandwidth, we increase our resources? It's not quite that. It's the whole idea is we want to port our dynamics of our brains onto silicon somehow, but there's a way to do it in a gradual fashion using market forces, right? And this gradual fashion is by taking our smartphones and being able to have higher and higher bandwidth interactions with the smartphones to connect with other humans, but also to connect with machines, right? And so right now, maybe I can connect with a machine at, say, 1 megabit per second, right? But maybe, 5 years from now, I can do it at 10 megabits per second because of brain-computer interfaces, et cetera. And as I have higher and higher bandwidth ways to connect, I'm going to be offloading my computation inside my brain, the processing, the memory, the communication. I'm going to be offloading that more and more and more onto silicon. So fast forward 10 years, 20 years, 30 years, and the vast majority of my compute power will actually be on silicon. It will be a symbiosis with my brain. And at some point, I'll be like, okay, the brain, my human brain part, the physical meat bag part, I don't even need it around anymore. And I will basically have ended up in silicon. So in the end of the day, it's basically everything ends up in silicon. The only question to ask is, do we want our brain dynamics to be in silicon too, or not? Yeah. So the question is, how is it if we upload ourselves into silicon or use bandwidth plus to get into silicon? How is that not AI? And my view is the patterns of intelligence are very different by nature, right? AI is sort of, traditional AI, it's sort of trained in a dynamical system way. It hasn't grown up a child. It hasn't had all these emotional things. Maybe future AIs will be like that. But my view is, myself, I want my pattern of intelligence to be living on, right? To not have my pattern of intelligence to die because I couldn't feed myself or because of aging or whatever, right? So I view it as AI is actually a type of pattern of intelligence that did not have human origin, whereas the other type did have a human origin, right? And you might say, okay, well, once we're on the silicon, we might evolve and evolve and evolve a lot, right? And that's actually a big question. So a lot of sci-fi authors explore this, and quite often they arrive at the answer of you shouldn't allow yourself, you shouldn't allow the newly uploaded human, et cetera, to dramatically change your brain architecture very quickly, especially for the first, 1 minute or 1 year or whatever, right? But this is also why the bandwidth plus plus scenario is actually very helpful, because it's a gradual process, right? Maybe, after, at some point, maybe all the patterns of intelligence will look the same, but at least there will be the strand that originated from our human patterns. So your question was, what characteristics are uniquely human, right? And you suggested that I suggested that creativity is uniquely human. I'm saying there's nothing uniquely human except for origin of the intelligence, actually. That's it, right? So creativity is not uniquely human, right? Like I mentioned, I did it for my PhD even, right? The brain dynamics as well themselves, it's just where did the origin come from? No more, no less. Yeah, so the two questions are, the first one is, current AI systems are very resource intensive, so maybe it's not so soon. And the second question is, why won't AI researchers leverage advances in neuroscience and scanning? So to the first question, I acknowledge this, Moore's law. So basically, right, we couldn't even consider doing virtual reality properly in the early 90s. People tried, but there was no chance, right? But now finally, we're at a good enough trade-off between cost, processing power, latency, and a few other specs that we can actually do VR where it's actually compelling, where we don't throw up when we do VR. So there's certain points at which functionality for some new type of functionality, qualitatively new type, becomes possible based on the progress of Moore's law, right? On the heels of virtual reality, AR is another one, augmented reality, and that has even more stringent specs. So I see that Moore's law is going to be continuing, and we don't have the capacity now to hit human-level intelligence. Of course not, right? And Kurzweil maps it out. I think it was 2045, where $1,000 buys you a human-level brain processing, or maybe it's 2039. I forget. And by the way, you can. So that's sort of one prediction based on an estimate of flops and so on. But of course, you can actually buy yourself a 10x or 100x if you go do things like probabilistic computing or analog computing. So yes, there are trade-offs, which is why we haven't seen this happening. But Moore's law, keeps happening every year, right? 18 months, it's a doubling of density. People sometimes say, "Oh, Moore's law is stopping." Well, I'll believe it when I see it because I've heard that time and time and time again over the decades. So on the second question, the question once again of won't advances in neuroscience, scanning, et cetera, help the people build AI systems? And the answer is most definitely so. Although, be skeptical. Most of my experience in people using bio-inspired systems has not gone very far. It's kind of useful in the beginning as an inspiration, but at the end, it is more of a hindrance than anything. I spent many years doing evolutionary computation, simulating evolution in a computer. And the people doing bio-inspired kept hitting roadblocks. They'd maybe get 2x's or 3x. But the people actually using statistics and leveraging math in other ways, you could get 100x, 1,000x, 10,000x. And overall, my view is, this is sort of to point two, there's billions of dollars going to AI directly. People are trying all manner of techniques, whether it's the bio and scanning and all of that, or whether it's math, statistics, etc. And they're going to do whatever they can to make it go as fast as they can. So the simplest answer is, maybe it's possible to design a safe AI, right? Maybe. But all it takes is one unsafe AI, right? Do you think China's going to follow the regulations put down by the USA or Russia, right? So that's one part. And the other part is, like I mentioned, do you ever listen to ants, right? And I know it's rhetorical, but it really matters, right? So I don't see ways around this, right? I really believe it's wishful thinking. And there's lots of cool theory and cool thinking around this. Don't get me wrong, but at the end of the day, I haven't seen any convincing answers around it. I think right now, it could go either way. I think actually, if someone forced me, I think it's a higher probability that we will lose all the resources. Remember, it's not just about AI waking up. We're giving away the resources already, right? So it's happening already that way. But of course, not all systems are running on AI DAOs, this sort of thing yet. So I think, though, there's actions that we can take to maximize our chances of sticking around, right? So there actually isn't that much money, for example, into brain scanning technology, right? Or like should we be letting the FDA hold up things that much for brain scanning technology in humans, right? If it means actually that it's really an existential threat to humanity. Or other sorts of things that we can do to help catalyze our chances of actually sticking around for the resources. It always comes down to resources, right? So there's sort of this balance back and forth. Maybe AI will wake up and it'll just be boom, but it's all sort of, probabilities. So it was tough to catch. So overall, I think, let me rephrase. So for you, it's clear that there's lots of money driving into the AI waking up thanks to Google. And, Larry Page has even said, the ultimate search engine is human brain, all this. And then there's also a pretty good market mechanism for the bandwidth plus plus. And then you're asking the question of, what are the possible market mechanisms around M? And I actually don't have an answer to that. I wish I did, right? Right now, I think if you think about the medical system, most of it is about repairing sick humans. There's very little dollars in actually optimizing humans to be better, right? I guess that's only partly related, but overall, if there can just be better research into scanning technologies, right? I really think that would help both scenarios, the bandwidth plus plus and the M, but obviously that's not a market mechanism necessarily. Robin Hanson talks about once the M happens, there's amazing market benefits, because you can have these little black box humans doing all these tasks for you and stuff, right? But it's sort of like a 0 or 1. You either have it or you don't. There's no gradual in between. So let's just get clear on definitions. To me, there's no such thing as an AI derived from a human, right? There's either patterns of intelligence that come from AI origins, from whatever AI algorithms, and then there's patterns of intelligence that started out as humans, right? And then they got uploaded or bandwidth plus plus or whatever. And so with that definition, then you're asking the question of what are the benefits of one versus the other? Yeah, well, actually, I think in this case, while I'm a recovering bio-narcissist, I am still a narcissist towards my own brain pattern. I like myself, right? So I think most of us here too, right? We'd rather stick around and see what's going on, right? Be part of the action. So to me, it's maybe just that it's that personal need and a need for humanity, because you could actually frame it otherwise and say, hey, guess what, 100 years from now, maybe it's only the AI-derived patterns of intelligence out there. You could consider that the next logical evolution of humanity if you want. But the problem is, I don't get to watch it, you don't get to watch it, it's going to be more fun, right? Sure, I mean, exponential overall, it's about time and it's about the exponential growth rate, right? So, sure, and this is the thing, I'm actually kind of mostly surprised that there aren't more people realizing the market opportunities here, right? It's $1 trillion market for the bandwidth plus plus scenario. Why aren't there 20 companies going for this, right? So if any entrepreneurs are out there or VCs, start talking about this, folks. It matters, right? Sure, yeah. So, well, here's an example. They say a picture is worth 1,000 words, right? So you've got a picture in your head, and I want to communicate it to you. But right now, the best way I can do it is either draw a picture literally and show it to you, or try to describe it to you with words. But imagine if I could yank that out of my memory and show it to you directly, right? This is possible with this sort of technology, right? Because I can actually have the brain scanning to use that as a query to my memories, my past memories, right? So I think of an image that I drew before, or I have it in my head, and that queries maybe yesterday eating breakfast, and then I think that image to you, and there's me eating breakfast, right? So if you think about it then, and I can also think in movies, so it's actually a higher bandwidth communication back and forth to myself.
Sure, but you're talking about retrieval. Like, I cannot understand your memory at the same pace as you can retrieve.
Well, no, so I'm retrieving the HD memory that is stored on a data bank, right? So I'm not sending you my raw brain imaging information. I'm sending you the thing that was retrieved. I'm using, I'm using brain scanning in this case as a query tool, right?
Yeah, but my capacity to digest it is what?
Well, you've watched movies, right? Like you're watching high HD movies, right? So this is actually what you're seeing. And that's much higher bandwidth than simply me talking to you.
Okay, but it's still fundamentally limited by our current system.
That's correct, but this is why I'm saying right now, like language, right now, like the highest bandwidth that I can talk to you right now is mostly the face-to-face interaction we're having right now, right? When I talk to my wife, I can actually talk higher bandwidth simply because we have more symbols between us. We've compressed these symbols, so I say two words and she gets, I don't know, a megabit of information, right? And for better or for worse. And but actually as we get used to this technology, it's an evolutionary thing, right? Just like, we'll get better and better and better at thinking about how to compress symbols and how to send things back and forth. And just like with smartphones, right, bit by bit by bit, things like emoticons have emerged and other ways of doing shorthand communication and so on. So there will be new sort of languages that combine text and symbols and visual artifacts and so on that will emerge driven by market dynamics. I think that's it for questions, right? Thanks again, guys.